Welcome to this video. In this one, I'll be showing the behind the scenes process of a 3D scanning and 3D printing job for a specialist car garage. First things first, I scan the exhaust manifold under controlled lighting in the studio. You'll notice I place tracking markers all over the part, and these become really important later on because I can't scan the whole manifold in one go. I have to scan it from multiple angles, then stitch those scans together in the software using the tracking markers to help align everything properly. The customer's goal was that they needed plastic blanks that would fit over all of the openings of the engine part, so the inside could be protected during the blasting process. This saves the customer time because it keeps everything inside clean and helps avoid damaging the internal areas of the engine part. To create those blanks properly, I needed a complete 3D file of the manifold. That way I could see the full shape of the part as well as exactly where all the openings in the bolt holes were. Because of the shapes, curves and awkward angles, trying to measure this properly by hand would have been extremely difficult. You could take some basic measurements with calipers, but getting the full shape exactly right from those manual measurements alone, that'd be almost impossible. That's why 3D scanning was needed for this job. It captures the real world shape of the part and gives me an accurate digital reference to work from. So the scan itself doesn't instantly become the finished part, but it gives me a clean 3D model that I can use as a foundation to create something more accurate for the blanks. So overall, this is a pretty simple workflow, but it's just super important that I get this 3D file completely accurate. So now you can see from this footage that I'm on the third scan of the exhaust manifold, capturing it from a different angle than I did before. So this is what helps build up the full 3D file because each scan captures a different side or section of the part. The top section of the manifold was without doubt the trickiest part to scan because the area is so thin and there are a lot of shadows and darker spots inside the opening. But the Creality Raptor Pro was holding up well, mainly because of all the tracking markers I'd placed around the object and on the desk. So even scanning from the top down, it could still keep tracking without losing its position. So on the left side of the screen, you can now see that I'm manually removing all of the unwanted tracking data from each scan before fusing the mesh from each scanning angle. This is important because I only want to keep the data from the actual manifold, not the marker data from the surrounding objects I'd strategically placed around the desk. You can see from the footage on the right that the exhaust manifold has now been turned onto its side. This allowed me to capture another scanning angle, especially around the underside of the part, including the opening pattern and all of the bolt hole positions underneath. I did lose the screen recording footage for this underside scan, which is kind of annoying, but you can still see the physical scanning process on the right. Hopefully the footage on the left is interesting as well, because that shows the cleanup stage where I'm removing the unwanted tracking data before fusing the mesh from each scanning angle, and that kind of connects the two clips. As you can see here from the footage on the left, all three scans have now been fused, which means the next step is aligning the fused meshes together to create one complete 3D file. The auto alignment feature in Creality Scan software actually worked really well here, and lined everything up properly without needing any manual alignment from me. It also shows why the tracking markers are so important earlier, because they gave the software enough reference points to work from. You can see here I'm panning around the mesh in the 3D viewer to show you just how much detail has been captured from these three scans alone. Here you can see the remaining scans of the underside being aligned into the main 3D file. This captured the last of the bolt holes, openings and underside shape, giving me a much more complete 3D file to work from. The red areas here show the gaps in the scan data. I'm automatically filling these because the inside of the manifold wasn't important for this job. What I needed was a clean outside reference to create the blanks from. You can see what we're working with now and how clearly the bolt holes, openings and overall shape has been captured. This gives me a really solid reference to start creating the blanks from now. At this point, I was ready to start creating and printing the blanks, but first I had to scan the second object that fits onto the manifold. This is now the last scanning process for the project, and once this part was captured, I had all the reference data I needed to move into the designing stage, to start creating these blanks. I'm thinking of turning this into a bit of a video series, showing real-world 3D scanning projects and the behind-the-scenes process of how the work is actually done. So if you've got any comments, questions or feedback on this video, I'd really appreciate it. My business is called Blueprints 3D, and I use 3D scanning, CAD and 3D printing for all sorts of real projects like this. You can check out the website through the link in my bio if you want. On there you'll see a bit more about what I do and some of the other projects I've worked on. The next project I'm planning to show is a 3D scanning job of an ornate 10-part chandelier stem that was basically on its last legs, For that one, I'll be scanning each section, cleaning up the files, and 3D printing the parts to create a replica. I've worked on some really cool projects recently, including restoring a broken fountain piece from the 1800s, on-site scanning of larger sculptures, and even scanning real animal skulls to turn them into 3D printed replicas. But anyway, let's get this project finished. I imported the 3D mesh files into Blender and used them as a reference to create the 3 new blank files. These were made to match the openings and bolt positions from the scan, ready to be 3D printed and test fitted. So now we're on to the exciting bit, 3D printing the blanks. After all the scanning, alignment and Blender work, this is where the files finally start turning into real physical parts. You can see just how well this side cap fits into place. Once it's bolted down, it should create a tight seal over the opening, which is exactly what the customer needed. The next part to be printed was the bottom blank, and this was the one I was really looking forward to. Here I'm just removing it from the print bed, and this was the moment where I was hoping all the scan data and design work had paid off. Once I held it in place on the underside, the fit was exactly what I was hoping for. For a part completely made by scan data, this is always the bit that matters most, seeing it line up properly on the original object in real life. The top cap was really satisfying because that fit was tight enough that it could actually be twisted slightly into the top opening by hand. That's episode 1 of the Scan to Print series complete. Thanks for watching, and I'll see you in the next one.